Good afternoon, everybody, or good morning, rather. My name is Caitlin. I am going to be presenting the polls that we usually go through. Sometimes in the past we've been going through them such that you just answer them. So I'm just going to actually walk everybody through them and kind of show you what everybody is choosing. So I'm going to go ahead and launch the first poll. So the first poll is, when using a compression analysis, what do you typically work with? Are you using thermoplastic materials, reactive material, any material, or do you not actually run compression and molding? Is this the first time learning about the experience, I guess? So I'll run through these for a couple more seconds. So it looks like not many people use compression molding, so this will be a new experience for everybody. So that's good. I can share that with you also, those results. So I'll go ahead and ask the next question. If you are using compression molding analyses, what is the most confusing during the setup process? Is it assigning the properties, meshing, molding, or just understanding those results? All right, thank you everybody for selecting one of those. So I'll share the results. It looks like assigning the properties is the most confusing. So that's good. We'll get into that a little bit today as well. And then we have one more poll question that we'll go through, and that is, what is your role in part design processes? Is it designing the parts, designing the mold, designing the part and mold, and so forth? So I'm going to go ahead and close that up. So it looks like the majority of the users review the part and or mold design, so that's good. So today we have Kristen Kilroy and Jay Shoemaker, whom most of you are very familiar with, and they will be going over the compression and injection compression molding within simulation Moldflow. So with that, I'm going to go ahead and hand that over to Kristen.
Thanks, Kate. Hi, everyone. Welcome again. As Kate mentioned, I'm going to talk a little bit about compression molding and then also go over a little injection compression molding. As the polls questions showed, most of you seem to be a little new to these types of analyses. So we'll go ahead and kind of run through some background on it and maybe do a demo for you. So just a quick overview of what this webinar is. It's previously been called a Hangout. We're changing it to be more of an overall build your simulation knowledge base. So it can cover anything from, as shown here in previous Hangouts, DOEs or process settings or cooling analyses, and we're continuing to build on that in the future. All our previous Hangouts are actually posted on our YouTube channel at Autodesk Sim 360, and we're going to begin starting to call these Build Your Simulation IQ as well, so you can just browse through those videos and take a look at those. We also do this for our other simulation products. such as simulation CFD, mechanical, and composites. So it's a great way to kind of introduce you to the other programs as well. Now we usually announce this through the forums, LinkedIn, direct emails, and through social media. So most of you probably have heard about this through the direct email that we send to the current subscription customers. So in the future, if you want, or if you're interested in looking at future Hangouts, keep an eye out on those other resources also. Okay, I just wanted to go over briefly what's in the news with simulation Moldflow. Since this is a Moldflow webinar, I did want to just kind of introduce you guys to a couple of the beta programs that we have in our Autodesk Labs website. These are available to customers who are currently using simulation Moldflow. So the first one there, Project Scandium, is a tech preview of the next release that has some additional features in there. And for instance, it has items such as solver changes, 3D microcellular molding, ejection force plots, and a few other kind of neat new features in there. So I'd recommend taking a look at that, seeing if that might be something that you can provide feedback for us and we can help improve it for the future release. Project Sundance down there is also a new beta program that we're showing. It's similar to Autodesk Structural Alliance. So if you're typically exporting a lot of your results into an FEA program, this could be something for you to take a look at, and it's for nonlinear structural simulations. So you could take the Moldflow results and put it into your FEA program via Project Sundance. So if you're interested in that, like I mentioned, you can go to labs.autodesk.com and take a look at that and see if it's right for you. The next thing I'd like to just briefly mention is our knowledge network. The support staff here at Autodesk have been creating articles based around things that we know users are looking for, as well as cases that we get in for support issues. So once we resolve a support case, we typically go through and write out an article. And each week, each day, we're producing more and more articles. And these can be found through knowledge.autodesk.com. And listed here are just some of the new articles that were published for anyone to view via that Knowledge Network website. And as you can see there, it's kind of just a variety of different issues that people come up with, or how-to cases, and it could help you through. If you're stumped, take a look at that website and see if there is an article for you to look through in the future. All right, now into compression molding. Today what we're going to do is talk a little bit about what analyses are actually available inside of Moldflow Insight for compression molding, and then discuss compression molding process and the injection compression molding process. And then we're going to follow it up with a demo with the coaster mold as shown in the picture there. Jay Shoemaker, who Kay had mentioned earlier in the presentation, he is going to actually kind of talk a little bit about the coaster mold, because he was actually able to run it. So we'll go ahead and start with the analyses available inside of Moldflow. So with Moldflow Insight, there are several different molding processes available for you to choose from, but these are based on the license level that you actually have. So in order to access the processes that we're going to talk about today, so injection compression molding and compression molding, you actually will need an ultimate license or else the flex license or the Moldflow 360 license. Again, with the flex license, it will cost cloud credits for that, so that's something to also consider when you're running these. Now with compression molding, since many of you indicated with the pools that you're kind of new to this process in Moldflow, compression molding is usually used for electrical applications or automotive or even compression with the addition of composites molding. This is due to dimensional stability, low stresses, and low clamp force. So it's definitely an option for kind of simpler parts in there for you to mold. Now whenever you're modeling the geometry for a compression molding simulation, there's a few things to consider. The first thing is the initial charge. As you can see in the photo there, the charge is the blob of material that you're using to actually fill the mold up. So you're pretty much taking that material and placing it into the mold shown on the right there. Now when you're modeling or simulating this in Moldflow, you will actually need to model this initial charge. This is so we can get that volume, the volume of the material that you're placing into the mold in the simulation, so it knows how much material is there. Now the next item is the part. You'll also have to model the part in your CAD program to be able to pull it into Moldflow. Now many people do it in an assembly, which is appropriate. You can do an assembly of the part and the charge and import that into Moldflow. Now the question we often get is if the charge should be touching the part. That doesn't necessarily have to be the case. What Moldflow does is actually, if it's easier to model the part or the charge above the part, say offset a few inches or so, you can actually, or what Moldflow does is actually move it towards or to touch the part surface when it first starts solving the simulation. So you can model it on the part or offset it from it. Orientation is definitely a thing to consider when you're modeling because Moldflow uses the z-axis as the compression plane. So the mold goes positive and negative x to compress that material. Now, when you're looking to mesh the part and charge, one thing to consider is to make sure there's several layers through the z direction of the part thickness. So this is so that the material can stretch as it's being compressed, and Moldflow will be able to capture it with these additional layers in there. When I say several, I typically recommend about 6 layers or more, just so it can capture that stretching of the material. The internal mesh of the charge is actually not as important as the overall outer surface, so pretty much what Moldflow is recognizing is the volume within that structure of the charge. So the number of elements throughout that thickness is not as critical as for the part. Now once you have the part and charge imported into Moldflow, one thing that you'll want to take a look at is the process settings. As you can see here, it is pretty different from the general injection molding process settings wizard. As you can see, the compression direction is listed there. As I mentioned, this is where you would either specify a positive or negative compression direction. If your model is not oriented correctly in that, you might get results that don't necessarily look right to you. So one thing would be to just verify that it's in the Z direction. If not, you can go into the geometry setting in Moldflow and actually just rotate the entire part to that Z axis. The next option there is the pure compression press open distance option. Now this is just how far the press is initially open. So typically you can leave it on automatic unless you have it unless you have an idea for where you know the press is going to be open to. The press compression time is the amount of time that the compression is being applied to that part. So once that time expires, the mold will no longer move. And the next two options there, the press speed cap and press compression force cap, those are kind of self-explanatory. It's the maximum speed and maximum force that the press will apply towards that compression. Now these are all things to consider whenever you have an idea for the press that you're using. That might be a better indication on where you'd want to put that marker at. Right now these are kind of the default settings in there that we used in this screenshot here. Now that next grid area there, the press compression speed versus distance, this is where you can actually almost profile the compression speed of the press. So if you want the, say you're compressing a part and you want it to go one speed for a certain distance and then slow down for another distance. This is where you can do that and kind of enter in, say you want 10 seconds at speed 5 and then even put in one after that and do maybe 5 millimeters at speed 2 to slow it down. Now the next option there, switch to press force control. This is kind of similar to switchover in injection molding. So it's where you're switching to the force control, so it's holding it in the tool there. Here you can have several options. You can either do it via percent nodes as shown there. That would be however many nodes are filled according to the solvers. Then you can also choose from the start of compression, when the press force reaches the compression force cap, or you can also specify it by time if you have an idea for when that would be ideal. And then the following option right there, compression force after switch to press force control. This is where you can specify if you want to control it via percentage or actual tonnage being applied to the part. And now we'll move on to injection compression. Some of the applications, again, these are also used highly for dimensional stability, low stresses, and clamp force, and low clamp forces, as with compression molding. So some of the applications here would be optics, communications such as casings, and then automotive. So some of the things to consider with injection compression modeling would be the CAD model itself. You want to make sure that when you're creating the model, the dimensions are the final dimensions of the part. So with injection compression, what is essentially happening is two stages. You're doing an injection phase with the press or with the mold slightly open, so there's a small gap in there, and then you're going to go through a compression phase in which it's going to actually compress that material into the remainder of the mold. So those photos there kind of show it happening. You can see that small gap there, and then once it's closed, force is applied to the mold, it's closed, and it compresses that material to all the gaps in the mold. Now, this is where some people get confused why I mentioned the final part dimensions, because often we get in product support, we get questions on if it should be modeled in with that gap included in there. This is where I'll get into in the next page here, the process settings. You can actually specify that distance, that gap, so it shouldn't be modeled in your CAD model. As you can see there, under the compression direction, there's an option for press open distance. That's where you specify that gap. The rest of the process settings here are similar to the compression molding settings, so I won't go through those again, but it's essentially the same process, except you're adding that initial injection phase. Here I'd like to just show a quick example of an injection compression simulation in Moldflow. This is the pressure plot for a part, a two-cavity part. As you can see, here's one cavity, here's a second cavity, and then this is the feed system here. So I'll go ahead and play that. And you can see the injection phase here, and then up here you can see the compression where the part's kind of compressed to fill that remainder of the part. So it is slightly different from compression molding in that the part's pretty much filled to your desired amount prior to the compression beginning. Okay, now I'm going to pass it over to Jay for a little bit and talk a little bit about the coaster mold that he was able to run. Jay?
Good day, everyone. Can anybody hear me? Uh-oh.
Yep, we can hear you.
Oh, okay.
I can hear you.
Phew, didn't hear anything. Okay. Anyway, for those of you that are on the line that know me, I also teach at Western Michigan University, and just happened to be doing Western's version of Plastics 101 this semester, and we just went through a compression molding demo. And being at Western, we don't have the biggest equipment in the world, so we have a couple of manual compression molding presses that have two versions of coaster molds. And so this last weekend I went through and made a few. In fact, the black ones are made of phenolic and the white and red are made of BMC material that we had for this. And next slide. And so for those of you that actually haven't seen compression molding, the shot is fairly important, and so we would weigh out a certain mass of the shot or the charge, place it in the mold, put, in this case, because it's a reactive molding material, put it in heated press and close it up. And so one of the things we can do with the compression molding simulation is look at different volumes or different masses for the charge. It will, the simulation will tell you if your charge is too small or way too large. And you can also get a sense if it's positioned incorrectly in the part. Now clearly a part this small, it would be virtually impossible to position the charge where I couldn't get a full part. But that is one thing we can do for the larger compression molding problems, even in cases where we have maybe more than one charge placed in different positions. We could play around with the size and location of those charges. Next slide. And there's another shot of the press closed up. And in this particular case, I used almost 30,000 psi to push it home, and for that mold that was a little bit too high. I flashed into the ejector pin and around the ejector pin, so getting it out was a bit of a problem, but that's another story. And with that, I think I'll pass it back over for the demo.
Thanks, Jay. Yeah, it's always a pain whenever you get that one shot that has a little too much flash in there. All right. What we actually did was Jay actually helped me out with this. Yeah. Jay actually provided me with the model to this coaster that he used. So I'm going to go through and show you kind of the basics on how to set up an injection or a compression molding analysis, excuse me. So as you can see here, I imported the charge, which is this blue part on top here, and then the part itself, the CAD model of the part down here in green, and then went through and meshed it. For injection compression molding and compression molding in Moldflow, you have the ability of doing the analyses in either midplane or 3D. This presentation is mostly focused on 3D, so I just continued that on to this demo here, but you could certainly play around with the midplane option as well. So once you have the part meshed like so, what you're going to want to do is, first things to make sure it's set to compression molding. So up here in the process selection window here, you want to scroll down because it's most likely defaulted to injection molding. If you scroll to reactive or thermoplastics compression molding, that's where you can get additional options to make it that type of an analysis. So once here, I just want to verify the material we're using, and then the next step is to actually assign the properties to these elements. So when you select the charge elements, just right-click on that and change property type, because initially they're going to all be set to part 3D. However, since that's the charge of the part, you're going to want to switch it to initial charge here. Select OK. Confirmation. And then that's all set. Now for the part, It is considered a part, so some people might get confused with the properties in there, because it is set to Part 3D. However, since it's a compression surface, so this whole thing is being compressed, we're going to want to change it to compression element. So we'll go ahead and do that. And then that's pretty much all set to go. Now, as I mentioned during the presentation, you can go into the process settings, and if you know the settings that you want to run, you can go to curing time here, melt conversion, percent air mass, so if there's any air in there, and then the next slide here goes to that same process setting page that I had showed you. So here we're just going to leave everything to pretty much default, just for the purposes of this demo today. Click Finish, and then to spare you the time it takes to run this, because I think this one took about an hour or so to run. I actually already ran it for you. So if we pull up the log, okay, so it took a little bit more than an hour. But here's where you can actually get into the results of it. So with the fill time plot here, we'll just show that. You can see the actual shape of the charge on there, so that geometry does have an effect on it. And since that's showing 0 there, as I mentioned earlier in the presentation, it's initially, or the Moldflow solvers are actually taking that charge that's actually raised up above the part right now and placing it on the surface elements of the part. So we'll go ahead and play through the animation, give you an idea for what's happening. And you can see the compression starting, and the part starts to grow as that material is being compressed. Okay, so here we've got pretty full part, nice fill pattern. We'll go down to some of the other results of the compression molding. So here's one that's kind of a neat one to look at, compression surface property. So sometimes if you have a complex part, you're not really sure if Moldflow is actually recognizing the proper surfaces, because initially if you look in the process settings here, or excuse me, let's select an element here, properties. If you go in this compression surface properties, it's going to actually default to automatic. So in this case, you can take a look at this plot here, the compression surface property plot, and it'll show you what Moldflow actually assigned for each of the surfaces here. So here we've got the moving surface, so this is the surface that's being, that the mold's actually pushing down on, and the element, or the material is being spread across it. And then the sides here, they're recognized here as the actual side of the part, so that could have some movement also with the compression moving down on it. And then finally the fixed end, which is the bottom half here, that's not seeing any movement in there, it's just kind of there as a cap almost to stop the compression. Alright, this next plot here shows the cured layer fraction. This is, since I'm using a reactive compression molding analysis, it's going to show the cured fraction throughout the part. So in this case, it's all cured throughout it by the end of the cycle. And then what we'll do now is go into, as I mentioned earlier, that geometry does show an effect on the surface of the part here. So what we actually did was run the same part but with a round cylinder charge instead. So here I went through the same steps that I showed you earlier, imported this charge and the part, meshed, and then went through the process settings and so forth just to confirm they're the same. And then here we go. That looks a lot cleaner for a nice rounded part. So if you want uniformity, it is a good idea to maybe play around with the geometry of the charge, and you can see how that affects the fill pattern of the simulation. So we'll just run through that real quick. And there we go. Okay, great. So the next thing I'd like to just show you real quick is if you have too small of a charge. So Jay mentioned that you can kind of play around with the location of it, and Moldflow will show it. That's more in the X and Y planes here. However, what if you don't have a big enough charge to fill the part? Now in this case, I actually halved the volume of the original one here. So this one, if you look under the log files, it'll actually show a warning message that there was not enough volume to reach the part full. So let's see here. Oops. And here we go. Here it says short shot. And then these other errors here are also here for just because we had default settings on, we didn't really optimize the high temperatures occurring. So there we go. And you can see in the log here it recognizes that the mold halves do close completely and no further displacement of the mold halves will move. All right, now we'll show the actual results up here to give you an idea. So as you can see, it shows the part filling pretty much the same pattern as that original one that I showed you. However, since there's not enough material in that charge, it's going to stop partially and leave a short shot for you. All right. Now this next one here, I created a charge that was twice as large as the original one. So here you could see there's a lot of material to fill that small part. Looking through the logs on this one, it'll also show a warning in here. And if I can find it here, okay, right here. If you look at that, the percent volume filled at end of compression is 208%. So instead of the 100% to fill the part, it's twice that and going to cause for flash to occur. And then if you scroll down here, you can look at the compression surfaces also. Moldflow actually does not simulate the actual flashing of the mold. This is something, like I mentioned, or like I just showed you, that you actually have to kind of look in the log here just to see kind of where everything's at and get a feel for how it's actually performing. So see here, it has the same settings. Since it was set to automatic, it recognized the same elements. And cured layer fraction. Here, what's happening is the polymer is actually curing prior to it being able to fill the whole charge in there. That's kind of why there was that short shot indication there. But like I said, you should take a look at that volume that's actually filling the part just to make sure there's no extra flash occurring there. You want that to be at about 100% or just below that. And at that, I think what we're going to do is open the floor for questions, unless Jay, do you have anything else to add to that?
Nope, sounds good. I'm busily typing up a question right now, but I'm
Okay.
free, or we're both free to take any questions also.
Okay. Kate, are there any questions on there, do you see?
Yeah, it looks like a question did come through. I'm not sure if this is the one Jay is typing up or not, but he certainly might be able to answer it. We can just answer that live, Jay. That's not an issue.
How to decide the geometry of the charge since it affects the flow? Remember, if we can go back to the pictures of the coaster mold and me setting it up, you could see the, right there. You can see the shape of the charge on the scale and the shape of the charge in the tool. You know, they're slightly different shapes, and in fact, it's the same volume and material. I just kind of rolled the one sitting in the mold in my hands a little bit to change its shape. So the compression molding I've seen with BMC, that's, you know, very much the case. You got some mass of material that's important, and you're going to put it in the tool. Now, as your tool gets larger, the exact positioning of that charge may be a factor, and I've also seen cases that I have not worked on where there were literally multiple charges put in the tool. So the position did become important, and the shape of the charges were more like flat sheets rather than a solid blob. So I wouldn't worry so much about you know, getting the precise shape, because it's going to change shot to shot, but the approximate size and shape. And where to get started with it is, if you're just really not sure, I would talk to the production folks and see what they're doing for similar parts. And, you know, playing around with your simulation as well, you can get a sense for, does the size or shape and position of the charge really make a difference, and that is something that you can clearly play with in the simulation.
And Jay, I'd just like to add, you mentioned doing multiple charges in there.
Yep.
Moldflow is able to have multiple charges in there. So as long as they're in contact with that surface, the part surface, then that will show that in the simulation as well.
Exactly.
Thanks for answering that, Jay. It looks like we have some, and Kristen, but it looks like we've had several more questions come through. Here's a question.
That.
Yeah, we'll just answer them live. It works well, keeps everybody engaged. So this one comes from Nate. So hello, Nate. He is asking, could this work for a coating or glue application with a super high aspect ratio?
Yeah, I'm looking at that question right now. My initial thinking would be no, but I guess it really depends on what are you trying to get out of the simulation? What are you trying to see? Is it like you're putting some volume of glue in one location, then you're squeezing it together and you want to see how that glue spreads out under pressure. Um, the issues that I think we would have would come down to understanding the viscosity of that material, which of course we'd have to test for and so forth. I said my initial answer is no, but it you know, is a maybe. Maybe you could reach out to the support team and we could talk more specifically about your problem and formulate an approach for you.
Okay. Yeah, Nate, if you want to create a case, you certainly can, and we'll help you like Jay mentioned. The next question is it possible to have different mold temperatures for the moving or fixed parts?
Good question. Excellent question. I don't, we've got a fixed mold temperature there. What I don't remember is, Kristen, click on an element of your model, right click, go into properties, and go into mold properties. So the answer would be no there.
No.
And if you, yeah. Paul, you're here.
Yeah, I'm sure, yeah, it would be there, otherwise you'd see it in the solver. So you could go into the
Yeah.
process settings and under the solver. And that would tell you straight
So that
away.
would, yeah. I didn't think the answer, I thought you had to use a single mold temperature, but it is worth verifying. And I think we answered Nathan's next one. Can we use several charges on one compression element? The answer to that is yes. Can we import the temperature profile? No, unfortunately. And I think all the other questions sort of relate to that first one in terms of glue and how it spreads out. And as we mentioned before, we can set up a case and look at that in detail, but I think it'll boil down to getting the appropriate material characterization for the glue.
Hey, Jay, I'm
So,
not sure if you saw this one come in, but Michael Porter's asking, can you give a charge at temperature?
yeah, I did see that. I guess I just missed it.
Yes, I believe there is. Let me try and remember where that was.
It may be on the charge
Transfer
itself.
Transfer pot
Oh, yeah.
temperature here. So that's where you could set the initial temperature of that charge, right?
No,
And then you
that's
can
not
also,
it.
no, that's something else. Whoops.
Just right click on that element on the charge itself, it may be there. No.
Well, wait a minute. This is go back to the process settings. The melt temperature is the charge temperature.
Gotcha. Yep.
little terminology.
That makes sense. Good catch.
Is it possible to run a DOE analysis for compression injection molding?
Excellent question. So if we go over to optimization, right-click, go to DOE, click OK, and then say click on variables up at the top. And yes, you can. And those are the types of things that we can set up for the compression molding. So virtually any process that we can run in Moldflow, we can do a DOE on. Now, one of the things that we cannot do in the DOE is change the position of the charge, the volume of the charge, things like that. Things that the DOE will have are related to values that we can put into the process settings wizard.
And to also expand on that, we actually did one of these webinars with DOE. So I'd definitely take a look at that on the YouTube channel for the recording of it. There's some useful information about DOEs in there as well. All right. Any more questions?
Yeah, it doesn't look like too many more questions are coming through, so we'll give it about another minute or so and then wrap it up.
Okay. And if you come up with any questions after this presentation, what you can actually do is post it on the forums, and we'll just keep an eye out for them. And be sure to watch out for those questions.
Alrighty, with that, like I said, we'll go ahead and end the webinar. I want to thank everybody for joining today. We really appreciate it. I hope everybody got something out of this webinar. It will be posted to YouTube, as Kristen mentioned previously. So with that, thank everybody for coming, and we look forward to seeing you next time.